This is for Year 11 Specialist. Question 10. We're going to do another proof. So in this case, we're trying to prove that the altitudes of a triangle are concurrent. That is, they meet at a point. So we're trying to prove that all the altitudes of a triangle, given triangle, any triangle, meet at a single point. So let's start our proof. We need to draw a triangle. So I'm just going to draw a random triangle. And I'm going to label it A, B, C. We're going to have two altitudes. One altitude going from here, and we know altitudes join at right angles to the base. Similarly, this altitude here joins right angles with that base. And we'll call the point where they meet up at being x. We need to define our vectors, so we'll define the position vector of A being just A, OB, B, OC, C, and OX, X. Now, what we know is that the altitude and the base meet at 90 degrees. So we know that the dot product of these two vectors would be 0 because they meet at 90 degrees. Now, I can call that A1 and B1 phi 1. I know that A to A1 and B to C would meet at 90 degrees, or the dot product would be 0. Similarly, we know that since we don't know what A1 is, A1 could be anywhere because we're talking about this generically for any triangle. We know, what we do know is AX. We know that AX, since it has the same direction as A to A1, we can use AX dotted with B to C, and we'll know that the result of that will be 0 because the direction's the same. So it doesn't necessarily matter what the length is, as long as we're dotting the right direction with the right direction, we know that the resulting angle will be 90 degrees. So let's use that fact. So we'll go AX dotted with BC, and we know that equals 0. So we can rewrite AX as X minus A dotted with C minus B, and we know that equals 0. So expanding this, we get X dot C minus B dot X minus A dot C plus A dot B equals 0. I've just expanded this expression. And we'll call this equation 1. So in a similar vein, I know the vector Bx and the vector AC. So Bx and AC, since it's part of the altitude, or the direction of the altitude, we know that they will have a dot product of 0. Now, I rewrite Bx as X minus B, and AC as C minus A, and we know that equals 0. So X dot C, when I expand this, I get X dot C minus X dot A minus B dot C plus B dot A, and I'll call that equation 2. Call this equation 2. And what we'll notice is that these two equations share something in common, share a few terms in common. Now what I can do is, like simultaneous equations, we're not quite solving for using this to solve simultaneous equations. I can subtract one equation from the other, and I get X dot C minus X dot C is 0, minus B dot X minus X dot A is plus X dot A, minus A dot C minus B dot C is plus B dot C, A dot B minus B dot A is just 0, so, and this whole equation equals 0, because 0 minus 0 is 0. Now what I can do is take a common factor out So I can take an x out, and we know that is a minus b. Similarly, I can take a common factor of c out, because we know they share common factors. So I'll highlight this to make this clearer to everyone. So I'm factorizing in pairs. So I'm taking an x out here, and I'm taking a c out there. So I'm factorizing in groups. So I'm factorizing this group with this group. Now, why am I doing this? It will become apparent because I get b minus a equals 0. Now, b minus a and a minus b are just negatives of each other. So if I take a negative version of this, negative x, if I take a negative out, I'll get b minus a plus c, b minus a. Now, what you will notice is they both share a common factor. Both terms have a common factor. I can take that out. And what I get left with is b minus a as a common factor. I take that out. I get c minus x equals 0. Now, if we look at our original triangle, what is b minus a? B minus a is the side, this side. So we're talking about this side. B minus a is this side. C minus x, we're talking about a line going from here to here. It's saying the dot product of them two, there's a dot here, the dot product of them two is 0. So what this is saying is the altitude of C to AB can extend past x into AB, and we know that it crossed at 9 degrees. So in doing this proof, we've shown that all the altitudes of a triangle actually meet at point x. And they're all altitudes because we've shown that the dot products of each one equals 0. So this is a very nice way of proving using vectors that the three altitudes of any triangle are concurrent and meet at a point.